This video covers lesson 7-2 for Secondary 1 Math, the Pythagorean Theorem. Did you know the Pythagorean Theorem is named after the mathematician and philosopher Pythagoras, who lived in ancient Greece around 550 BC? Well, Pythagoras was not the first mathematician to notice the relationship between the two legs and the hypotenuse of a right triangle. The Babylonians, the Chinese, the Mesopotamians, and the Indians all have records that show that they knew about this relationship. But Pythagoras is usually credited with producing the first proof of this theorem. So what's the Pythagorean theorem? We see that right here. The Pythagorean theorem states that if a triangle is a right triangle, then a squared plus b squared equals c squared, where a and b represent the lengths of the two sides, and c represents the length of the hypotenuse. So the sides a and b are usually referred to as legs. I have shown these in the image on the left in red, the two legs, a and b. And c is referred to as the hypotenuse. So the hypotenuse is that third side length, which is labeled with a c, or now as you see in yellow. So there's three things to remember about the hypotenuse. The first thing is that it is always across from the right angle. It is always across from the right angle. Second, it is always the longest side. It is always the longest side. And third, it is always c in a squared plus b squared equals c squared. It is always c in a squared plus b squared equals c squared. The Pythagorean theorem states that the sum of the two sides, which we refer to as legs, squared is equal to the square of the hypotenuse. So we're going to take a look at this example, and we'll just break it down to give one specific example. Here we're given a right triangle, and we know it's right because it has this little square in the corner. Now we're going to say that this side over here is 5, this is 4, and I'm not writing it in the actual squares, okay? But this is side length, this is 3. Now we're going to create a little grid to show us that these are 5 units long, 4 units long, and 3 units long. Now the Pythagorean theorem states that if we take the two sides, or the legs, and square them, so that would be 3 squared plus 4 squared, right? The sum of the two sides squared, that should give us the hypotenuse squared, which is 5 squared. So we're really saying visually, this square, right, the area of this square, plus the area of this square should equal the area of this square. Because when we square a number, we're really looking at the area of a square that has a side length of that size, that number. So back to our equation, 3 squared is 9, 4 squared, 16, and 5 squared is 25. And well, 9 plus 16 is 25, so that worked. Now, we knew it was going to work because we were given a right triangle to start. Okay, but now we're going to look at the converse of the Pythagorean theorem. And that's what it says here. We can use the converse of the Pythagorean theorem to determine if a triangle is a right triangle. Now the converse of the Pythagorean theorem, I'm going to underline it, states if a squared plus b squared equals c squared, then the triangle is a right triangle. I love the if then. So if I can show this, then this is true. So number 1. Show whether or not the three side lengths form a right triangle. We got 29, 20, and 21. So the first thing we got to decide is which one is C, or the hypotenuse. So C is always going to be the longest side. If we look up above, it says it's always the longest. So it's going to be the 29, because that has the greatest value. It doesn't matter which side length you use for A and B, but those are the other two. So we got 20 and 21. Now, if you wrote them as 21 and 20, it doesn't matter. Now we're going to substitute ABC into the Pythagorean equation. So this is how we're going to check. So we're going to go 20 squared plus 21 squared. And we're going to see, is this equal to 29 squared? So this is the question. We don't know for sure, even though I put an equal sign there, we're not sure it's equal. We're going to test it. So we're going to do 20 squared, which is 400. And then we're going to add 21 squared, which is 441. And we're going to see, is this equal 29 squared, which is 841. And we look at that, 400 plus 441 would equal 841. So this is true. So we're going to say true. And since it's true, that means that these three side lengths form a right triangle. For these next three problems, we're going to show whether or not the following triangle is a right triangle. So number 2, we have the lengths 10, 12, and 8. Well, first we want to identify which one's the hypotenuse, or C. So we look for the longest length, which is 12. So this is C. The other two, it doesn't matter. So I'm just going to write out our Pythagorean Theorem equation. So 10 squared plus 8 squared equals 12 squared. And 10 squared is 100 plus 8 squared, which is 64. And we're going to see if that's equal to 12 squared, which is 144. Well, as you can see, 100 plus 64, that will not be 144. That's 164. So these are not equal. So I'm going to put a slash through my equal sign. And we're going to say not a right triangle. Okay, number 3. We have this triangle. It has side lengths 24, 10, and 32. Well, the longest side length is 32, so that's going to be our C. And we're going to substitute now. I'll just call 24A and 10B. It doesn't matter which ones they are. And we can set up our Pythagorean Theorem equation. So 24 squared plus 10 squared. And we're going to see if this is equal to, again, this is the question, is it equal to 32 squared? So 24 squared equals 576, and 10 squared is 100. So we're hoping that 32 squared is 676. Now we put it into our calculators, 32 squared, and we get 1024. So again, this is not equal to, put my slash through, so not equal, so we say this is not a right triangle. Okay, number 4. Again, looking at our triangle, the longest side length is 51. So that's going to be our C. So we're going to have 24 squared plus 45 squared. And we're going to see, is this equal to, that's the question, is it equal to 51 squared? Now, we use our calculators, pull them out. So we have 24 squared, and that's 576. Oh, that's nice. That was on number 3 too. And then we're going to add 45 squared. 45 squared, that's 2,025. And then, is that equal to 51 squared, which is, again using our calculators, 2,601. So if we add 576 to 2,025, we get 2,601. So this is true. This is true. Yay! Okay, so this is a right triangle. Now there's one thing I need to point out about these types of problems. It said show whether or not. Okay? So I have to show all of my work. If you don't show your work, you're simply making a statement that could be true or false. So make sure you show your work so that you're supporting and justifying your answer. Alright, the Pythagorean triples. Now Pythagorean triples is just a set of 3 natural numbers that always form a right triangle. As we saw in example A, the set 3, 4, 5 forms a Pythagorean triple. That was the example we did with our grid inside the squares. A few of the most common Pythagorean triples are listed in this box. So you can see some of them over here on the left, and then you have more over there on the right, but those are related differently. Another way to find a Pythagorean triple is to multiply a Pythagorean triple by a common factor. So think about your 3, 4, 5. If we multiplied all of those numbers by 2, we would get 6, 8, and 10. Look, that's the next one right here. Or if we took 3, 4, 5 and multiplied by 3, then we would get 9, 12, and 15. And that's this third one in the list on the right-hand side of our screen. So this list can continue depending on what we multiply the 3, 4, 5 Pythagorean triple by to get us a long list of different right triangle Pythagorean triples. Now, we could do it with any of the common Pythagorean triples that you see on the left side of the screen. Okay, so people went through and just found all of these, and now they're there. And we could go find them all, but we're not going to take the time to do that. Okay, but what we need to do is make sure we remember how to use the Pythagorean theorem. So here for 5 and 6, we're going to solve for the missing length. We're going to write your answer as a simplified radical and as a decimal rounded to the nearest tenth if necessary. So the first thing we got to do is when we're looking at our right triangles, we got to decide which side length is the hypotenuse. So number 5, we have the side lengths 12a and 18. And notice that 18 is across from the right angle. So the 18 is the hypotenuse, or C. So now we can use A, and we'll call 12b. And I like to label them so I know which one's which. And I'm going to set up our Pythagorean theorem equation. So a squared plus b squared equals c squared. Now I should have substituted in. I'll do that now. So we have a squared plus 12 squared equals 18 squared. Now a squared just stays a squared. 12 squared is 144. 18 squared, well, I'm going to use my calculator. 18 squared, that is 324. And now I can subtract the 144 from both sides of the equation, which gives me that a squared is equal to 180. Now to find a, we need to take the square root of both sides of this equation. So we get that a equals the square root of 180. Now I got to simplify that square root, but before I do that, I'm going to get our approximation. And to find that approximation, I'm just going to type in the square root of 180 in my calculator, which results in me getting a is approximately 13.4. Now I need to add my units. This is in feet, so 13.4 feet. Now to figure out the exact value of a, I'm going to go ahead and do the prime factorization of 180. And that goes down to 10 and 18, which goes to 2 and 9, 9 to 3 and 3, 10 is 2 and 5. So I'm noticing that my prime factorization, and I'm going to put this at the bottom of the screen, but it's going to be the square root of 2 times 2 times 3 times 3 times 5. And so I'm going to get a 2 and a 3 out of the square root. So 2 times 3 is 6. So I'll have 6. And then inside I'm going to have the root or square root of 5. And then don't forget your units, feet. So the exact value of a is 6 square root 5 feet. And the approximate value of a is 13.4 feet. Number 6. We have this right triangle, and it has side lengths 48b and 73. Well, notice right here across from the right angle is 73, so this is C. And the 48 will be a side length, A, and then we have B over here on the other side of the triangle. Now that we know the side lengths of two sides, we can find the missing side length. So we set this up in the Pythagorean Theorem equation, and we write 48 squared plus b squared equals 73 squared. Then we use our calculators. 48 squared ends up being 2,304. And then we have plus b squared, which is equal to 73 squared, which is 5,329. Then we're going to subtract the 2,304 from both sides of our equation, which results in b squared being equal to 3,025. At this point, we're going to go ahead and take the square root of both sides to find the value of b. And when we do that, putting in our calculators the square root of 3,025, it comes out to be 55. Now we just got to add our units, centimeters. Now we don't have to do anything else because that came out nice. So this is our simplified square root or simplified radical. And we don't need to find an approximation because it came out exact. Okay, number 7. So we got 20 yards, 48 yards, and c. So here we're solving for the c. That's our hypotenuse. So we're just going to substitute these values in. So it doesn't matter what we label them. I'll just call this A, this will be B. So we got 20 squared plus 48 squared equals c squared. At this point, we just do 20 squared, which is 400. And then we're going to add 48 squared. In our calculators, we find this to be 2,304. We're going to add those together to get c squared. So 400 plus 2,304 would be 2,704. Is equal to c squared. And then we're going to take the square root of that number. So when we take the square root, we get c is equal to 52 yards. Remember to put our units on. And again, it came out exact, so that's our solution. We don't need to do anything else. Number 8. We have this right triangle, and we have side lengths of 25, 50, and b. So notice across from the right angle is 50, so that's going to be our value for c. And then 25 will be a. So we got 25 squared plus b squared equals 50 squared. Now we're going to use our calculator, and we'll get that 25 squared is 625. Then we have b squared equals, and 50 squared is 2,500. Subtract this 625 from both sides of our equation, and we get that b squared equals 1,875. So then we'll take the square root, and we find that b is approximately 43.3 meters. So there's our approximation, but now we've got a factor. So we're going to do the prime factorization of 1,875. So I'm going to do a little scratch work here. We got 1,875. Prime factoring this, I think we're going to get a 5 out here. So 1,875 divided by 5 is 375. Now that can factor down too, so we get 5 times. So again, 375 divided by 5, and we get 75. Now 75 is divisible by 5 as well, and it's 5 times, here's our calculators, divided by 5, 15. And 15 is 3 times 5. So without even writing this in my square root, to simplify that square root, we see the pairs. We got 2 5s here, and then we got a 5 and a 5. And then we have a 3 left over. So we're going to have a 3 left in the square root, and then 2 5s out. And 5 times 5 is 25. So we're going to say the exact simplified radical for b is 25 square root 3 meters. Okay, number 9. we have A, 21 and 29. Again, 29 is across from the right angle, so that's going to be our C. And then we'll put the other two into our Pythagorean Theorem equation as well. And we get the equation A squared plus 21 squared equals 29 squared. So we have A squared plus 21 squared, which is 441, equals 29 squared. So using our calculators, 29 squared, entering that in, we get 841. So now we're going to subtract the 441 from both sides. And we get that A squared is equal to 400. So taking the square root from both sides, we get that A is equal to 20. And it's an exact, so we don't have to do an approximation or simplify our radical expression. So we just say it's 20 inches. So A equals 20 inches. Number 10. So we have the right triangle and has side lengths of 39 millimeters, 65 millimeters, and A. So across from the right angle is C, which is going to be the 65 millimeters. Now, writing our Pythagorean Theorem equation, we would have A squared plus 39 squared is equal to 65 squared. We're going to have to use our calculators for this one. We got A squared plus 39 squared, which using our calculators, we can find that to be 1,521 equals 65 squared, which is 4,225. Then we're going to subtract the 1,521 from both sides. 1,521. And I'm going to use my work. I'm going to move up here to the right. And we get A squared equals 4,225 minus 1,521, which is 2,704. And I think we've seen this one earlier in today's notes, the 2,704. But we got to do it. So we're going to take the square root of both sides. Again, using your calculator, it's the square root of 2,704, and we get A is equal to 52. And then our units, millimeters. So 52 millimeters. 52 millimeters. All right, we have two problems, 11 and 12. And for these problems, we need to plot the given vertices of a triangle. Then we're going to use the Pythagorean theorem to find the missing side. Write your answer as a simplified radical and as a decimal, rounded to the nearest tenth, if necessary. Okay, so number 11, we got the point -3, -4. So we're going to go from the origin, left 3 and down 4. That's going to be our first point. Then we have the point 5, -4. So we're going to go right 5 from the origin and then down 4. And then we're going to go right 5, because 5, 2, and up 2. So right 5, up 2. So here's our right triangle. And you can see it's right. It's already got this square in there, right? Right triangle. So over here is going to be our hypotenuse. That's what we're solving for. We don't know that length. But the other sides we can actually count. So we have 1, 2, 3, 4, 5, 6 is our side length here on the right. And then counting across from the bottom, we got -3 over to 5. That's 8. So we have those two side lengths. Now we're going to find the missing side length, the hypotenuse, by substituting what we know into the Pythagorean Theorem equation. So the Pythagorean Theorem equation that we'll have is 6 squared plus 8 squared equals c squared. So 6 squared is 36, 8 squared is 64. So we have 36 plus 64 is equal to c squared. Then we're going to add those together, which gives us 100 is equal to c squared. And then take the square root. And we find that c is equal to 10, or 10 units. So the hypotenuse is 10 units long. Number 12, we have the point -8, 5. So we'll go left 8 and up 5 from the origin. Then we have negative 8, 1. So left 8 and up 1 from the origin. And then 0, 5. So over 0 and up 5. So we have this right triangle. Again, I know it's right because I can see this square here. Now we can count the two side lengths. So this vertical side length, 1, 2, 3, 4, is 4 units long. And the horizontal side length at the top is going to be 8 units long because it goes from 0 to negative 8. So we want to find the hypotenuse again, which is c. So setting up our Pythagorean Theorem equation, we have 4 squared plus 8 squared equals c squared. 4 squared is 16. 8 squared, again, is 64. And that's going to be equal to c squared. So if we add those together, we get 80 equals c squared. Then we need to take the square root of that. So we're going to take the square root of 80. So c is approximately, using our calculators, 8.9 units. Now we got to find the simplified radical expression here. So we're going to take the square root of 80 and we're going to find the prime factorization. So we're going to factor this down to 8 and 10. 10 would factor to 2 and 5. 8 factors to 2 and 4, and then 4 factors to 2 and 2. So the prime factorization of the square root of 80 would be the square root of 2 times 2 times 2 times 2 times 5. Now, remember, we want to find pairs to pull them out. We got a pair of 2's multiplied there. Another pair of 2's, so we're going to pull out 2 2's. And 2 times 2 is 4, so we're going to have 4. And then we're going to have a 5 inside. So 4 root 5 units is equal to c. And that's the exact solution, whereas 8.9 is our approximation for the value of c. This concludes the video for Lesson 7-2 for Secondary 1 Math, the Pythagorean Theorem.